Okay, I'm going to start with the geometry revision. And as I said, on Tuesday, we will have a long lesson. I'm going to start off with the basics, just explaining similarity, and I'm going to explain congruency, and I'm going to explain midpoint theorem. Okay, so I'll do it slowly. If you look at this diagram, it says TR is parallel to PQ. It also says angle S is 28. So what I will do, I think tomorrow I will just make it, super tricky. Just want to get my pen. It says angle S is 28 degrees. So today I'm going to explain all the basics, and then tomorrow I will just give you a more difficult one. TRS, right? TRS is equal to x plus 70. And it says angle P is equal to x plus 10 degrees. Calculate the value of x. Now, if I must quickly look at this, for me, it looks a little bit like similarity, doesn't it? If you just look at it, it looks like similarity. But for similarity, that's what I just want to run through. For similarity, so it's just like I'm doing it slowly today, going through the basics. With similarity, you recognize similarity with the three eyes, and congruency. Congruency is when the two triangles are equal to each other, but we don't write just two lines, we write three lines for equal. And similarity, write down three vertical lines, sharp. What do you need for similarity? If you sit with a small Christmas tree and you sit with a big Christmas tree, the one looks similar to the other one. Okay, I'm just admitting some more, right? So the small one looks similar to the big one. And why do we only need, for similarity, why do we only need two angles? So I just want to explain it, then I can cancel out again. With similarity, I just want to explain why you only need two angles. Welcome, Michaelan. Welcome, Josh. Tomorrow, I will also do a lesson, but I'll do it very complicated on the midpoint theorem. Today, I'm running through the basics. So with two similar triangles, for example, if this is 90 degrees and this one is 90 degrees, and let's say this one is 10 and this one is 10, why do I only need two angles? Sorry, because 90 plus 10 gives me 100. 90 plus 10 is 100. So it doesn't matter how small this triangle is. It means this angle will be equal to this one. 100, 90 plus 10 is 100, so we know that both of these will be equal to 80. But you only have to look for two angles. With congruency, the four reasons would look like this. And the two triangles must fit on top of each other. So the first one, I just work with visual stuff. Otherwise, I can't remember it myself. So I just work with visual things. Side, side, side. Then it's my mouse, my side, angle, side. So this looks like a mouse, all right? Side, angle, side. The third one is the one that's in the news and that's causing havoc. What is causing havoc at the moment? South African Airways. Side, angle, angle. And And the last one is your 90 degrees, your side, and your hypotenuse. So it's your right angle, your hypotenuse, and your side. There's often confusion with the 90 degrees because they can also give it to you like this, where the 90 degrees can actually be the included angle. So don't jump to conclusions, you know. Don't, if you see a 90 degree, just think, oh, okay, it's right angle, hypotenuse, and side. No, it can look like this, and then it's plane, side, angle, side. Right, calculate the value of x. So let's see, what will we do? We first look at what's given. Well, they gave us parallel lines. Now, they're not just going to give you stuff in the exam. So if they decide to give you a parallel line, you must apply what you know about parallel lines. Well, we know it's going to form a corresponding angle. So I know this one and this one will be equal. I know angle R will be equal to angle Q. You can all see it, right? Because it forms corresponding. Let me just explain corresponding. If that's parallel, you can either have a side on the left side of the parallel equal to the side on the angle on the left side, or you can have an angle on the right side equal to an angle on the right side. So then it's corresponding. Alternate, you know, it must be on both sides of the cutting line, right? So if that's parallel and parallel, alternate angles will be this. Welcome, Farsland.
Ma'am?
Yes.
Ma'am, I wanted to find out, since you said that when you look at a triangle, ma'am, even though you can see it's 90 degrees, would it be wrong if we said it is 90 degrees, but there's no 90 degree, that indicator's not there, ma'am?
Absolutely, it will be wrong. You take technical drawings, by the way.
No, ma'am, I don't.
I just thought you are guilty. Because you know what, in art, it's normally my technical drawing pupils that would say, oh, but that's 90 degrees, finished and klar. It's not. If they didn't indicate with a symbol here that it's 90 degrees, then maybe the technical drawings pupils will actually realize it couldn't, you know, it's possible that it can't be 90 degrees. Because I don't know if it's maybe 91 degrees. You see, Nati, what I mean? So
yes,
it could be slightly like that. But for us, it looks 90. But this might be 91 for all we know. So no, you can't assume. They must give the symbol. Right, so now this looks like similarity to me, but I don't have sides that are equal. I hardly have anything. But they force me to figure out x. That means you just go back to grade 8, working with interior angles of a triangle. Right, so the biggest thing with geometry is not finding the answers. The biggest problem is writing down the reasons in the proper order. That's normally the problem. And I would, just before I forget, I will WhatsApp you for the lesson time for tomorrow. Because it's Friday, pupils can just tell me what time would suit them. Those who are going for prayers, please just WhatsApp me what time would suit you for tomorrow. Tomorrow there'll be a class, Saturday there'll be a class, Monday, and Tuesday we'll have a long lesson. Then you should be fine. Okay, if I look at this, I'm going to work with my interior angles in this triangle, right? I'm just going to work in this triangle. So to get here, I'm going to say angle S is 28 degrees, that's given. Angle TRS, okay, angle TRS is equal to x plus 70, that's given. And then I'm going to say, because they gave us P, they didn't give us this angle T. So you have to say STR, STR is equal to angle P, and that will be equal to x plus 10. And the reason why I'm saying it is because it's corresponding angles.
Ma'am?
Yes.
Ma'am, why do you say angle TRS is equal to x plus 70? Why don't you just say angle R?
Plain because you see angle R can consist of R1 and R2. And because they didn't give me a 1 and a 2 on the drawing, Narty, they just referred here to angle TRS. So that's why I'm going the long way. You see, angle P can only be angle P, and angle Q can only be angle Q. But this angle T can also be on this side, like T1, and that side, T2. You can, in the exam, if you have the diagram on your answering sheet, you know, if it's together, then you can fill it in there. But don't do it if it's not like together, you know what I mean? Otherwise, they might lose your answer, you know, the paper itself. And then you talk about T1 and they don't know where's your T1. So if there's no 1 and 2 there, just work with STR to indicate this one. Right, so why would they be equal? Because it's corresponding, because TR is parallel to PQ. Right, then I'm going to say, now we can add them. It's interior angles of a triangle. So now I'm just going to say angle S plus TRS plus STR is equal to 180. Why? Because it's interior angles of a triangle. What I suggest you do when you listen to the recordings afterwards, or if you do revision and you listen to the past recordings, if there's stuff like this that's sort of very easy for you, then just forward wind, you know, just forward wind the video. Like when I look at a series, I don't look at everything. It's such a waste of time. So I often forward wind. Then I don't have to. Okay, not always, but I often do it. Okay, so I'm going to say 28 plus x plus 10 plus x plus 70 is going to be equal to 180 degrees. Now you grab your calculator, x plus x is 2x, 28 plus 10 plus 70. Okay, it will help if I put it on. Okay, it's plus 80 then, basically. It's 108. Okay, and then you just say 180 minus 108, which will give you 72. And that you divide by 2. All right, now it says for 8.2. Okay, so I'm going to go to the next slide. We just figured out that x is equal to 36 degrees. TRS was x plus 70. And they say we must figure out STR. Right. So for 8.2, I'm not just going to jump into it and say x plus 10 will be equal to 36 plus 10. No. Why is this one? Why is STR x plus 10? Because it's equal to angle P. So I'm first going to say that. You see, it counts 3 marks. So STR is actually equal to angle P, which is equal to x plus 10. The reason corresponding. Corresponding angles because TR is parallel to PQ. And now we know that X is equal to 36 degrees. Reason proven. Therefore, STR is equal to 36 plus 10 degrees, and that's going to give me 46 degrees. So this one is 46 degrees. Sharp. Then for the next one, it says, is triangle PQS a right angled triangle? Justify your answer. Okay, so that one is 28 and 46. Is triangle PQS? PQS. So do you see that we are going to work in the big triangle now? So I already worked out STR. So I'm just going to say here that STR is equal to angle P, and let's just give the reason again, corresponding. And I'm just going to squeeze in here, it's equal to 46 because we already proved that it's 46 in the previous slide. Corresponding angles, TR is parallel to PQ, right. So I already have my angle P now. This one is 46 degrees. Angle S is 28 degrees. And TRS. Okay, TRS was given. This one was X plus 70. So I'm going to say that angle Q will also be equal to X plus 70. Angle TRS is equal to angle Q is equal to X plus 70. And the reason again, corresponding, right? Because TR is parallel to PQ. So just be very thorough with what you are saying. So therefore, X plus 70 is going to be equal to 36 plus 70. And that's going to be 106 degrees sharp. Now for the last step, in order to prove whether it's a right angle triangle, what are, oh, I was stupid. This was unnecessary. This was unnecessary. This wasn't needed. What was only needed? Only this is needed. So I would just also squeeze in here that X is equal to 36 degrees. Why? Proven, because we proved it. And now I'm going to say, therefore, TRS is not equal to 90 degrees. You see, we just worked out this one is 106 degrees. So therefore, triangle PQS is not a right angle triangle.
Ma'am?
Yes.
Ma'am, why are you saying therefore TRS is not equal to 90? Why are you putting that reason there?
Okay, okay. I'm putting it in here because they're asking. No, it's not TRS. Thank you, it's Q. Therefore, angle Q is not 90. Thank you. Because they said, is triangle PQS a right angled triangle? So PQS, so it means, will there be, you know, if it's PQS, a right angled triangle? Yeah, why did I specifically work with Q? You know what? You're putting me here on letting me think here. I don't really, it's like being like Inati now. This, for me, was the closest one to 90 degrees. But what would be more correct, I think it's Carlene's voice, eh?
Yes, ma'am.
Yeah. What is more correct here is to say, therefore, not any of the angles are equal to 90 degrees. You see, so anything here that makes sort of sense. So this would have been fine. This would have been fine. And then I can say, therefore, not any of the angles. Because I mean, what if this was 90 degrees? You see, then it would have been a 90-degree triangle. Although it's sort of obvious this is an acute angle. Therefore, not any of the angles are equal to 90 degrees, and therefore this is not a right angle triangle. Okay, makes sense now, I hope. Because it's equal to 106, it's not 90, because for a right angle triangle, one of the angles must be equal to 90. Okay, with this one, in triangle ABC and triangle PTS, angle B is 70 and angle P is 70. And the question says, prove that the two triangles are similar. So what do we know? We know if two triangles are similar, we are trying to find two angles only. Okay, so we must try and find two angles. Now let's analyze what's given here. This is a line and this is a line. So it means the y will be equal to 15. I sit here with a 5 and another line there. So it means this one is also going to be equal to 5. But what else do I see? This one is 70, because remember now, they said we must prove that it's similar. So for similar, I must work with my angles. So if I analyze this, can you see this angle opposite that side will be equal to this angle opposite that side. So this one will be 70 degrees. Let's analyze this triangle. This angle is opposite this 5. Therefore, this angle will also be equal to 70 degrees. Okay, so now I can work with similarity. It's not really necessary to have 3 angles like I previously demonstrated. You only need to have 2 angles. 70 plus 70 will be 140. And 140 plus 40. So we know this one is 40, but you don't have to work it out. You only need to have 2 angles. 70 plus 70 is... Yeah.
Ma'am, I don't understand what you're doing. Like I'm lost.
Okay.
Ma'am, are you still gonna...
Sorry?
Are you still gonna write it down?
Yes. Yes.
Oh, yeah.
The first thing that we must know is that we must prove triangle ABC is similar to triangle TSP, right? What do you want for similarity? You want to have 2 angles that are equal in one triangle and also in the other triangle. So what I have so far, I've got these 2 angles in this triangle will be equal to these 2 angles in this triangle. What I just said is that angle A will be 40 and angle T will be 40 because of interior angles of a triangle. Do you see this? 70 plus 70 is 140, plus this 40 will add up to 180. So they will also be equal, but I don't need that. Okay, I'll do it step by step just now. Okay, so I'm taking it out because you don't really need the 40. You can work it out if you want to and just say it's 40. Doesn't matter. Just want to show you it's not necessary. And I just want to show you that they will both be equal. Right. So for similarity, how do you start? You always start in Okay, but before I'm going to actually do the proof, I'm going to say that angle B is actually equal to angle C is equal to 70 degrees, right? This angle B is equal to angle C is equal to 70 degrees. My reason, angles opposite equal sides, okay? Angles opposite equal sides. In this triangle, they gave us angle P is 70. So I can say angle P will be equal to angle S will be equal to 70 degrees. Angles opposite equal sides. Okay. Right, now I'm going to actually do my proof because I've got two angles and that's all I want. So in triangle, you always start with a question. In triangle ABC and triangle TSP, I can say, oh, by the way, this will always help you. If they give it to you in that order, you can always go and try and see if you can't possibly prove that angle A is equal to angle T. Because if it's similar, it means these angles will actually be equal. So this is for me always like a little clue or a little guideline to go and see if I can't prove maybe that these angles are equal. And can you see, we just worked with angle B, which is 70, and it's equal to angle S, which is also 70. So I'm just going to say angle B is equal to angle S, is equal to 70 degrees, proven, because I proved it there at the top. Right, angle C is also 70, and P is 70. You see, that one is equal to angle P. Proven, because I already proved it. Now for the third one. The third one is going to be angle A because we didn't work with A and we didn't work with T. So I can just say now that angle A will be equal to angle T. And the reason why they will be equal is because of interior angles of a triangle. Because that adds up to 180. And as I said, NK, 70 plus what? 70 plus 70 plus A will add up to 180. Just like with this one, 70 plus 70 plus T will add up to 180. And that's
Yes, ma'am.
yeah, I think you do see it now. Eh? So therefore, angle A will be 40 for both of them. But as I said, it's not necessary to say it. Therefore, now we end. We say, therefore, triangle ABC is similar to triangle TSP. And my reason is angle, angle, angle. That's your reason for similarity always. Sharp. Now it says that we must now, I just want to write down my similar triangles. It was ABC and TSP. Okay. Now they say in this question, determine y. Can we work out y? Yes, we know this one is 15. I can say y is equal to 15 units because there's no centimeters here. I'm just going to say given because this one was 15, therefore this one is 15. Then we must figure out x. All right. So that means I am going to work with my similarity. Take a tip from me. You always work with 99% of the time with what you just proved in the previous one. So I can say, triangle ABC is similar to triangle TSP. Why are they similar? Proven. We just proved it. And then we do this. We work with what I call the copies. Therefore, AB on top of TS will be equal to BC over SP. And that will be equal to AC over TP. Why would they all be equal? Because of similar triangles. Or you can also just say sides in proportion. You can either say similar triangles, or you can say sides in proportion. And the nice part then is what I enjoy is when we actually now just fill in the values. I have AB is 15, and we must figure out X, so we're interested in PS. AB and TS. Okay, we'll have to say here because I haven't said it yet. So just say it here somewhere. Okay, I'll write it there. TP is actually equal to TS. So you must just say what is the size of TS. And that's 5 units. Why? Because it's, you can just say given, right? It's given because this and that's because of the lines. Okay, let's move on. AB over TS. Now, TS, I just said there is going to be 5. BC is 12. SP is X. I don't have to continue with AC over TP. You see, that will be a waste of time. So if I have 3 known values, I can work out X now by cross multiplying. So 15 times X will be equal to 5 times 12. And X, therefore, will be equal to 4 units. All right. Happy? Right, let's look at this type of question. If they say, prove with reasons that triangle ABC is congruent to triangle DCB. Congruency, you know what we are looking for. Okay. Latecomers, side, side, side. The mouse, side, angle, side, side, angle, angle. South African Airways, right side, hypotenuse, side. So what I suggest you do, if they say you must prove 2 triangles are congruent and they intermingled like this, I would quickly just split them up. But if you can just see it, you don't have to split them up. Okay, so there's A, B, C, and let's look at D, C, B, right? D, C, B. Where my B is that one, and D is this one. Right, let's see. Prove with reasons that these 2 triangles will be congruent. So I already sit with 2 angles. So while I'm writing it down, You must try and look for the third one. So in triangle ABC and triangle DCB. Listen, I'm quickly just... Okay, could you see the three things? In triangle ABC, I'm going to say that angle A is actually equal to angle D. Why? Given. Right, I've got that one. Then I'm going to say angle C. Okay, what I also suggest you do, if you look at the naming order, ABC. ABC, there's your A, and DCB, so there's your D. ABC, so the C is a little cross, and DCB, so B is a little star. Angle C, okay, ABC, angle C will be equal to angle B. What's the reason? Given. Okay, could anyone see the third one? What else will be equal? Remember now, I can't say B is 90 or anything, but if you take ABC and you slide it back, Kaylin, can you see it? If you take ABC and you slide it back onto DBC.
Ma'am, isn't it the common side?
Yeah, thanks. Just checking if you're still okay. Yes, BC, can you all see if you slide it back, will be equal to BC because it will be the common side. And then we say, therefore, triangle ABC will be congruent to triangle DCB. My reason is South African Airways side angle. Sharp. So we sort of went through all the basics now. Just quickly a Pythagoras one, just to make sure you're still fine with that. BC is 8. I'm going to do this one very quickly. BC is 8. CD is 6. CD is 6 centimeters. AB is 26. AB is 26 centimeters. You must find the length of AD. Now, next year in grade 11, you will be doing triangles, working with trigonometry stuff. And I always suggest that you try to find the common side. Even now, if they give you complicated elevation angle things, you often have to work with a common side. You know, with the sine, cos, and tan ratios. See, if I must try and work out AD, I only have the 26. So it means you have to start in this triangle and figure out BD. So just again, I work with my two short sides, would be the 90 degrees, the short side, and BD is the hypotenuse. So to find BD, I'm just going to say BD squared equal to CD or DC squared plus BC squared. Pythagoras. Yeah, and don't just give up on maths, you know. Even if you do get 30s, you can still hang in there next year. It's just the first term is actually quite easy because you just do recipes to do the equations, so it's not that bad. Okay, BD squared is equal to DC squared, which is 6 squared, plus 8 squared. Remember, this year was hectic, so if your marks are not what you want it to be, you can still increase a lot next year by being very dedicated. So the square root of BD is 10 units. Centimeters. Yeah, so this year was a very depressing year. Next year it will just go better. And remember, if we as parents are depressed, then very often kids also feel, oh. All right, so I'm just trying to get you to not be negative. Okay, let's move on. BD I have now. So I said you often have to work with a common side, especially next year. Now I've got this one and I must work out this one. This one is a short side and this one is a short side. That is my long one. Always the hypotenuse, the one opposite the 90 degree. So I'm just going to say short one, AD squared is equal to the long one, AB, minus the other short one, which is BD, Pythagoras. But if NK wanted to say AD squared plus BD squared is equal to AB squared, he could have. You know, it doesn't matter. Okay, so AB squared is 26 squared minus 10 squared. Grab the calculator. 26 squared, 676. And that is 24. Yep. So you just get the square root. So AD is 24 centimeters. Sharp. For this one, you need to know the difference between the different properties. If this is a square, what do you know about the square? I will WhatsApp you all the properties because I think it's very important to go through them. With a square, all four sides are equal and the diagonals are all equal in length, right? The reason why is just because we sit with 90-degree angles. Then quickly the rectangle. I still have a midpoint theorem question. So with a rectangle, the angles are 90 degrees. And because it's 90 degrees, the diagonal pieces will all be equal. Then the rhombus is that mixture. They freaked out the matrics with the first paper because the first paper had a trapezium in it and some of them forgot how to work out the area of a trapezium. And that was for paper 1. But oh well, the paper was reasonable. Okay, so with the rhombus, because it's not 90 degrees at the side, all of these angles will not, all of the sides will not be equal. It will look like this. Very unique about the rhombus is that it has a 90 degree on the inside. And then the parallelogram. Opposite sides are equal because there's no 90 degree there. These diagonals will all be equal. And I see they also have a kite there. So with a kite, 2 pairs of adjacent sides are equal. And with the diagonals, you'll have a short one there and a long one here. And this one will be equal to that one, and there will be a 90 degree. Those angle sides are equal. All right. QS, it says here that PR cuts QS at T such that PT is equal to TR. And QT is equal to TS. And we must decide which of these 4 will it be. Well, you can see from this, it's not a kite because then there will be a 90 degree. So it won't be a kite because they must put in 90 degree there at least. It won't be a rhombus because they didn't indicate that that's a 90 degrees. So it's not a rhombus. It's not a rectangle because they didn't indicate 90 degrees. And if it is a rectangle, it means all the diagonals will be equal. So it will be a parallelogram. Okay, quickly, let's just look at midpoint theorem. You must recognize midpoint theorem. You always need to have two requirements. You can either have those sides and those sides to be equal. Then you know the third side, if you have this, if you have these properties, then you know this will be parallel, the sides, and the one side will be half of the other one. But you can have different requirements. You can maybe have this, a side and a side that's equal, and parallel. Then you know that the other side will also be equal in, it's in proportion, meaning this might be 2 centimeters and 2 centimeters, and this one might be 5 centimeters and 5 centimeters. And then, if you have these requirements or properties, then you know this one will be half the length of that one. Right, so let's see, what did they give us here? QR is 10, so let's fill it in. QR is 10, and PM is equal to MQ. PN is equal to NR, and we have PQ is parallel. Okay, PQ is parallel to SR, so let's fill it in. Before I forget while I'm busy with it, if they say something is parallel, I am already going to look for my alternate angles. Maybe I will never use it. I don't know. I just want to put it in. This one is parallel, so we can't work with the angle there. There's nothing there. What else? SR is 4. Okay, SR is 4. All right. Let's go for it. Now, we must determine the length of MN. MN. All right, anyone sees anything? Well, what can I say here? I can say here that in this triangle, I'm just trying to look for this type of scenario. So what do I have? I have this one is equal to this one. I have PN is equal to NR. So what do I know from this? From this, I know, well, and they gave us that is 10 millimeters. So from this, what do I know? I can now say that therefore, this side will actually be parallel to this one, and MN is going to be 5 millimeters. Right. How would you write it? I'm going to say in triangle PQR. I'm going to say that PM is equal to QM. Why? It's given. PN is equal to NR. That's given. Therefore, we can now say that MN will be parallel to QR and MN will be half of QR. And the reason is because of midpoint theorem. So I can say here, QR is 10 millimeters, that was given. Therefore, MN is 5 millimeters. Sharp. So I'm going to fill it in there. So this one and this one is, that's going to be 5 millimeters. And I know this side is parallel to this one. Next one, we must figure out PG. Oh, I suppose it was PQ because I don't see a G. Okay, so it was this one, PQ. Okay, how can I figure out this side? This one is 5. This one is half of that one and it's parallel. Okay, so I sit here with, see if I copied another slide. No, I didn't. So I'll just quickly do it here. Okay, quickly try and think out of the box. Now you must think of properties of a parallelogram, because I can't see how I can work with midpoint theorem starting from any of the other angles. But I must figure out the whole of PQ. But if I can maybe find MQ, then I'm sorted. So can you see, let's quickly look at this shape. M, Q, S, R. Okay. We can say that MQ is parallel to RS, right? That was given. You see in the beginning, they said this whole PQ is parallel to SR. So this one is parallel to that one. It's given. We just proved that MS is parallel to QR. Proven, because we just proved it now. So therefore, this shape is going to be a parallelogram. So therefore, MQRS is a parallelogram. Why? Because two pairs of opposite sides are parallel. Right? So it's a parallelogram. And therefore, I can say MQ will be equal to RS will be equal to 4 millimeters because it's opposite sides of a parallelogram. You see, that one is 4 and this one is going to be 4 millimeters. And then I can say PM is equal to QM is equal to 4 millimeters. Why? Because they said it was given. So therefore, PQ is 8 millimeters. Right, I hope it made sense.